Change the plans. We're going to do 2 lessons in one because they're so easy and because tomorrow we're going to have a shorter day, so I don't want to run out of time. I'd rather do a little bit more today and then continue tomorrow if we still need to cover more stuff. Let's begin with the first part, which is probability lesson number 2, and you have this entire detailed page of notes, great notes. It explains everything that you need to know, but right now for this lesson, for the sake of condensing it, we're going to chop it down a lot to this. So on your piece of paper, go ahead and write down probability. And let me tell you, probability is a fraction. The numerator of the fraction is what you want, and the denominator of the fraction is the total possible outcomes, right? So what you want over the total possible, that is probability. What you want over the total possible, okay? So again, it's a fraction, what you want over total possible. And of course, it could be a fraction, but you could take any fraction and change it to a decimal, and you could take any decimal and change it to a percent. So let's start off with something that we are familiar with. We all know what a die looks like, right? What if I said, what is the probability of rolling the number 5? And you know, when you write probability questions down, they usually use this notation, P, and then in the parentheses, they put whatever you want to happen. So the probability of a 5 on a die. So in order to answer this, we know it has to be a fraction. What is the numerator? It's what you want. So what do we want it to land on? The number 5. How many sides of this die has the number 5? Only one. So up on top, there's only one side that we want. Out of how many sides possible, how many total sides does it have? 6. And that is the probability of rolling a die and it landing on the number 5. Or the number 3 or the number 1. Any specific number, it'll be the probability 1 out of 6, right? So you could say 1 out of 6. You could give the fraction 1/6. You could even change that to a decimal. How do you change a fraction to a decimal? A fraction is really a division problem. It says 1 divided by 6. So if you do that on a calculator right now, go ahead and do 1 divided by 6. We'll get 0.166, and technically it continues, right?
Oh, it finished with a 7.
Yeah, and you could change that to a 7. Either way, that's your decimal, 1.66, and the 6 continues. And if you want to change that decimal to a percent, you could do that by simply taking your decimal and moving it 2 spaces to the right. Okay, and that will be, as a percent, 16%, or 16.6%. And if they tell you on your instructions, round it to the nearest percent, then it would be 17%. Does that kind of make sense? Okay, but right here on this first example, I want to show you the notation, P of 5, right? The fraction, what you want over total possible. So you want the number 5 out of, that's one side, out of the total possible sides, which is 6. This is your probability, that's a fraction. You could read it as 1 of 6 or 1/6. You could change that fraction to a decimal by dividing 1 divided by 6 on your calculator. And you could change that to a percent by moving the decimal over 2 places. Now, if I would have said round it to the nearest 1/10 of a percent, then it would have been 16.7 because the other 6 would change that to a 7. We'll get to the more details later. Right now, I just want you to understand that general idea. Now, not only that, I hope you guys draw a number line right here. Put a 0 on the left side, a 1 on the right side. And since we know that a probability is a fraction that could be written as a decimal, that decimal, if it's closer to 0, that's less likely it's going to happen. If it's closer to 1, it's more likely it'll happen. If it's actually 0, that means that it's impossible that it's going to happen. Like, let me tell you, what's the probability of me just starting to fly right now? That is 0, right? It's just, no, it's an impossibility, right? 0, okay? How about a situation where it's 1, or you could say 100%. Give me a situation in real life that you know for sure, like 100%, no doubt, fact, it's going to happen.
Someone taking a shower.
You're gonna die.
Someone taking a shower. Okay, no, there's some people that don't take showers. I like that one though. You're gonna die. Actually, I don't like that one, but that's very true. You're gonna die. The probability of you dying is 100%, or one whole, or 1.0. It's 100%, right? There's not that many 100. You know what? I've seen probability being used wrong. For example, and this is a true story. Last week, I was throwing out the trash. It was about 8 o'clock at night, and it was 8:19 at night. And I saw that it was cloudy. This is a screenshot from my cell phone in Imperial. And I was like, oh, it's cloudy. Is it going to rain? So I asked Siri, and she says right now, it's cloudy and 58. And that was at 8:19. But at 9 p.m., 100% chance of rain. What the heck? That is mathematically incorrect, right? Because they don't know for certain. And when I saw this, I'm like, dude, this is wrong, 100%. So what did I do? I stayed out there till 9 p.m. It didn't rain. It really didn't. Okay. So yeah, they should have put 99%, right? Or maybe 99.9, but you can't say 100%. That means it's absolutely going to rain. And that's like predicting the future, which what probability really is, but you can't be 100% certain of many things. So anyway, jumping to the homework, it's pretty straightforward and simple. This is not the homework that you have, okay? But this is very similar to it. Question 1, how many pieces are there in the total spinner? 8. Okay, now why would they ask you to find the total pieces? Because the probability is what you want over the total, right? So you're going to need that 8 in the denominator of your probability. So it doesn't matter which one you're looking at. Let's say if you spun the spinner one time, what's the probability it's going to land on a gray piece? Well, how many gray pieces are there? 3 out of the total 8. So the probability of landing on a gray piece is 3 out of 8. And on the answers, they specifically write 3 out of 8 or 3 of 8. But of course, we could, if we wanted to, change this to a decimal. Could somebody divide it for me? 3 divided by 8. Thank you. 0.375. And if I wanted to change this to a percent, all I'd have to do is move it over 2 spaces, and it'd be a 37.5%. Or you could round up and make it a 38% if you wanted to, because the 5 would round that up to an 8. If it were a 4, 3, 2, or 1, or 0, it would stay 37% if you were rounding to the whole percent. But again, the answer key only shows you the words 3 of 8. I would like you to write it as a fraction and then change it to a decimal and then change it to a percent. It's just good practice. And I will ask you specifically on the quiz, like, write the probability as a percent. I might even say write the probability as a percent and round to the nearest tenths, right? Or maybe round to the nearest whole percent. I don't know. So I think we get the idea. It's pretty simple, right? It's what you want over the total possible. Should we do another one of these? Number 3, number 4, number 5, which one? 5? Okay. What is it that we want? What do we want it to land on? Gray or white. Okay, so how many are those that are gray or white? There's 4 that we want out of the total, which we said was 8. And there's your answer, 4 out of 8. On the answer sheet, you're going to see that it reads 4 of 8. But a better answer would be 1/2, or 1 of 2, or as a decimal, 0.5, or as a percent, 50%. Get it? Got it? Good. We have some die questions, basic straight up probability right here. This one's cool. Number 7. What's the probability of not rolling the number 3? You don't want the number 3. So what do you say? 5 out of 6. If you don't want the number 3, that means you want 1, you want 2, you want 4, or 5, or 6. So that's a total of 5 that you want, but you don't want the number 3, which is only one side. So that would be a 5 out of 6 for number 7. 83%, yeah. If you change it to a percent, yeah. If you change it 5 divided by 6, that'd be a 0.83. And then you could change it to a percent, 83%, which is very likely that it's not going to land on a 3 when you roll it. Let's move on down here. What is the probability of randomly selecting a circle? I close my eyes and I just put my pencil and it lands on a circle. What's the probability of it landing on a circle?
6 out of 16%.
6 out of 16, right? And yeah, that's great that we're thinking percents, but let's begin with the basic fraction, what we want over the total possible. So if we're answering number 10, find the probability that it's a circle. Well, there's 1, 2, 3, 4, 5, 6 circles. So that's 6 that we want out of the 16 total possible. 1, 2, 3, 4. 1, 2, 3, 4. 4 times 4 is 16. There's a total of 16. So 6 out of 16 is the probability of it landing on a circle. Now, of course, we could reduce that. And on the test, I'll tell you, write it in reduced form or simplest form. So that'll be 3 out of 8. And of course, you could change that to a decimal. You could change it to a percent. Certain questions I will ask for decimals, certain questions for percents. Anyway, I think we got the hang of this one. Let's move on to lesson 3, which is definitely more entertaining. Before we move to lesson 3, see the answers, they just write it out, 4 out of 8. They didn't even bother reducing. This should have been reduced down to 1/2. But anyways, I would write it as a fraction, 4 over 8, reduces down to 1/2, change it to a decimal, 0.5, change it to a percent, also 50%. Anyways, lesson 3. Here we go. Again, on lesson 3, you're going to find a whole page of detailed notes. A lot of notes. Let's simplify this. Condensed version. Let's just write down the words compound probability. What does the word compound mean? Together, right? So when we start talking about different probabilities happening together, that's what compound probability is, okay? Now, you may have 2 different probabilities working together that have independent events, but then again, you may have different probabilities working together that have dependent events, okay? So let's begin by understanding the difference between independent events and dependent events. So independent means that one probability does not affect the second probability. Here's an example of it. What's the probability of rolling a die, it landing on the number 5, and flipping a coin and it landing on heads? Like both of them have to happen. You roll a die, it lands on 5, and flipping a coin and it landing on heads. Both together, compound inequality. What's the probability of that happening? Well, let's first start with the probability of landing on 5. So the probability of 5. What's the probability of landing on 5 on a die? 1 out of 6. Okay, good. And now, what's the probability of flipping a coin and it landing on heads?
50%.
Probability of heads, 50%, but as a fraction? 1 side out of the 2, right? 1/2. Now, when we're talking about both probabilities together as a compound probability, we're talking about multiplying them, okay? So let's multiply the 1/6 times the 1/2, giving us 1/12. And this is right here the probability of rolling a die, it landing on 5, flipping a coin, and it landing on heads. Is that likely to happen? Not really, right? I mean, if you were to divide it, 1 divided by 12, you're going to get something. What is that, something? So as a decimal, it's 0.083, and as a percent, it's 8.3%, right? But anyways, the answer, 1/12. These are compound probabilities where you find the probability of one, find the probability of the other, multiply them together. That's a compound probability. Let's take a look at another compound probability that's independent. Check it out. Whoops. What is happening here? Sorry about that, technical difficulties. How about the probability of flipping a coin and it landing heads 2 times in a row? So if I wanted to land, I don't know why I have this slash right there. If I wanted to land heads, what's the probability of that? Probability of heads, that's 1 out of 2, right? And what's the probability of it landing on heads a second time?
1 out of 4.
1 out of 2 again. So together, that'd be 1 out of 4. Okay? So 1/4. Now, why do we call these independent events? Because if you flip a coin and it lands on heads, and then you're going to do it again, the probability doesn't get changed, right? It's still a single coin and it still has one side that's heads and one side that's tails. Let's check out a dependent event probability, a dependent compound probability. Let me actually move this out of the way, make more space here. A dependent event, let's talk about a bag of marbles. You can't see the marbles, but inside this bag, you have 2 black, 3 blue, 5 red. It says, what is the probability of selecting 1 blue and then, without replacement, 1 more blue? Okay, so let's think about this. Let's start with the first thing that we want. We want 1 blue. How many blue are there?
3.
Out of the total, how many?
3.
Probability of blue. There's 3 blue out of the total 10. And of course, you got to do the math. What's 2 plus 3 plus 5? That's a total of 10, right? So this is a probability of reaching your hand into a bag that has 3 blue marbles, 2 black marbles, 5 red marbles. The probability of pulling out a blue at random is 3 out of 10. It's about 30%, okay? Not that likely to happen. Now, after you pull out that 1 blue, you don't replace it. That means you don't put it back in. All right, so you took 1 blue out and you put it to the side. How many are still blue in the bag? 2. There's 2 left. And that's what you want. You want to pick another blue. So the probability of another blue is going to be 2 now that you want, because there's no more 3. You took 1 out of how many total now?
9.
Only 9. Okay, so this is for sure dependent because of these words without replacement. Now, if it would have said with replacement, you pull a blue one out and then you put it back in and do it again, it would be 3/10 times 3/10. And that's what you would call independent of each other. But this one's dependent because it says without replacement. Once you pull that one of those 3 out, there's no longer 3 in there. Now there's only 2. So that second event is dependent on that first event. Because it's without replacement, these are dependent events. I hope that makes sense. Does it? Okay, so anyway, I still haven't figured it out. What's my answer going to be? 6 over 90. Okay? And of course, you could reduce. You could reduce to 3 over 45, and then you could reduce down to 1 over 15. And then you could change it to a decimal if you want by dividing 1 divided by 15. And then you could change that to a percent if you want. But there's your reduced fraction, 1/15. Again, these are dependent events because if you pull out a blue marble without replacing it, then the numbers change. So they're dependent. Let's take a look at, see there's a lot of notes right here, but let's just focus in on what we just mentioned right now. An independent event occurs with replacement. They're dependent events if there is no replacement. Because if you pull out a blue one, then it changes the number of blue ones. Not only that, if you don't replace it, if you don't put it back in, it also changes the total number that's in the bag. So when there's no replacement, you're talking about dependent events. When there is replacement, it's like, oh, there's 3 blue marbles out of the 10. You pull it out, you found 1 blue marble, you put it back in, you shake up the bag, you pull it out again, it's still going to be 3/10. So those would be independent when you have replacement, but they're dependent when there is without replacement, when you don't replace it. I don't know, maybe I'm confusing you guys. Am I? Or you guys get it? Let's see if you get it. Going to assignment 3 homework. Let's read number 1 right here. And let's say if it's I for independent or D for dependent. All right, so Anne draws a colored toothpick from a jar. Without replacing it, she draws a second toothpick. Those are dependent, right? Because like, let's say she pulled out a red toothpick and she didn't put it back in. Then the total number changes, even the reds change. So the second event is dependent on the first one. So these are for sure dependent because there is no replacement. There is no replacement. Let me highlight that. Without replacing it. The next one, John rolls a 6 on a number cube and then flips a coin and it comes up heads. Are those dependent or independent of each other? They're independent, right? It doesn't matter if you roll a 6 or a 5 or a 4. I mean, that probability doesn't affect you flipping a coin and it landing on heads. Those are really totally independent, right? They're only dependent when what you do with the first one affects the second one. Anyway, so yeah, this one's independent. And you guys could continue working right there, and we have answers. Let's move on to the second portion of the practice. It says, using two spinners, find each compound probability. And right here, number 6, this does not mean to multiply P times A and P times 2. No. This is the notation saying the probability of an A and also the number 2. Keep that in mind. The probability of A and 2 on these two spinners. So here we go. Probability of A and 2 both happening. All right, well, what is the probability of A? 1 out of 4. Okay, and we know we need to multiply it with the probability of 2. What's the probability of 2? 2 out of 6, right? And we could reduce it to 1 out of 3, right? I mean, we could say 2 out of 6, but that'll reduce down to 1 out of 3. So we're going to multiply the 1/4 times 1/3, and that'll give us our compound probability of rolling or of spinning and landing on A and also on 2. Okay, so what is the probability? 1/12. And yes, you could change that to a decimal. Yes, you could change that to a percent if you want. I'm just going to leave it 1/12. Okay, so we understand that. And these are definitely independent of each other. If it lands on A, it's not going to affect it landing on 2. Or if it lands on C, it's not going to affect it landing on 3. So these are totally independent of each other. Let's go to this one over here. These are compound probabilities that are dependent. Why do I say dependent? Because it says right here, there is no replacement. Okay, so let's take a look at the situation here. A box contains 3 red marbles, 6 blue marbles, and 1 white marble. And let's answer this first one. Let's find the probability of you pulling out a blue marble first, not replacing it, and then right after pulling out a red marble. Okay? So here's the math. What is the probability of blue? How many blue marbles are there?
6.
There's 6 blue marbles out of the total 10, right? We're just going to leave it at 6 over 10. We'll reduce later on, but right now the probability of picking a blue is 6 out of 10. So let's say you did pick a blue marble. What's the probability of now picking a red marble without putting the blue one back in? 3 out of, okay, let me actually write this down. The probability of red now. There's 3 out of, since you didn't put the blue marble back in, there's only 9 now down here. Maybe I should do this and, yeah, there you go. Does that make sense? So now that we know both the probability of blue and this dependent one, because you didn't put the blue one back in, now there's only 9 down here total instead of 10. We got the probability of red, that's dependent on that first one. Now we need to multiply them both together to get an answer, and I would reduce them to make it a little easier. 6/10 reduces down to 3/5, and 3/9 reduces down to 1/3. And if you multiply them both together, you will get 1/5. And that is your answer for pulling out a blue marble without replacing it, and then reaching in and pulling out a red marble. So this is it. I mean, you guys just need to work through this homework assignment and practice and check your answers. And this is going to be your, call this your study guide for the actual quiz. You will be able to use your homework assignments on the quiz. So it's good that you actually do it and you do it clearly so you could have it with you when you're doing the quiz. All right? The quiz will be based on these types of questions. Good luck.